Hello again.
Hello, Alex.
Again from it's like number five now.
Again, 5 times. Yeah,
Yeah, five agains.
over a month in now,
Yeah, which is good. Our
which is really good.
audience space is growing as well.
Yeah, yeah,
I've had plenty of views on the video, quite a few downloads on the podcast.
yeah.
So
People just enjoy listening to the industry, and we're the same, really. So
yeah, yeah,
yeah,
exactly. I'll move forward a bit so my ears don't disappear, which we've
yeah,
kind of discovered does happen. Doesn't happen.
yeah.
So this week we are talking about cell tower inspections.
That we are.
We
Um,
are indeed.
hmm Well, you've
Um,
you've recently captured a test cell tower, haven't you?
I have. I was
So,
out in the field last week,
mm,
in some pretty blustery conditions,
mm,
capturing a local cell tower.
hmm
And once you like any of these things, once you know what you're doing,
yeah,
it's actually pretty easy, and it's
yeah,
pretty and quick.
yeah,
Um, obviously you've got variables that can cause issues or give you slight problems, but as long as your planning's all in place, and you've planned the job correctly, and you when you're on site, you know what those obstacles are and what those dangers can be.
hmm
Then yeah, it's a pretty easy process, really.
yeah, yeah, yeah. Once you
Anything's
know,
easy when you know how.
yeah, exactly. Yeah. Yeah, you always have that feeling in you that, oh, if I knew this when if I knew what I know now, then I would have done it so much better. But then
Exactly.
that's the story with these things, really. So,
Yeah.
um, should we start with talking about cell tower inspections and why they are important or becoming
Yeah.
increasingly important?
Yeah, I mean, again, you've got the age old, how would you inspect back in the day, how would you have inspected a cell tower? Well,
Mm,
again, I don't know if they would use scaffolding. I don't really know a lot about cell tower inspection in the survey industry.
hmm
I'd assume you've obviously got most of them the bigger ones have ladder structures up the middle,
Yeah.
so you could climb up it,
hmm
which should be safe ropes, etc., etc. Cherry pickers for those ones that are in more built up
Yeah.
areas. I mean,
Yeah.
the one that I did last week was crazy rural,
hmm
in the middle of nowhere. But I assume for ones for like town centres,
hmm
you'd use a cherry picker or maybe some kind of scaffold tower
hmm
to inspect them.
Yeah.
But then drones come along,
hmm
as with most, with a lot of inspection work,
hmm
um, drastically reducing the time and the effort to be able to go and capture your asset.
Yeah. Yeah. And you can keep your feet safely on the ground as opposed to
Mm.
climbing these structures. So they lower the time, they lower the cost also from a risk perspective.
Huge
Um,
amounts of
you know,
risk mitigation.
yeah.
You know, well, I mean, at the end of the day, if your drone does slam into the side of a cell tower, mm, you may
Yeah.
damage the cell tower, and you're likely to damage your drone. But at the end of the day, you're not going to damage yourself.
That's right. Yeah. I mean, there's
Um,
the risk of cost of human capital versus infrastructure capital. I mean,
Indeed, indeedy.
mm.
Um,
But then you can also repeat it, right? Because it's just if I mean at the end of the day, you're using a flying machine to capture this thing.
but this is it.
Yeah.
If you've planned that mission and you planned it correctly, you can then go back and use the same automated mission
Mm.
time and time again to survey the same tower. You've
Yeah.
already got the data saved and the
hmm
mission saved.
hmm
So you could, if you wanted to do what like a lot of companies do, repeat their missions once a month or once every couple of months. You don't have to go back and go through the whole rigmarole of replanning, and they
Mm.
may have added parts. They
Yeah.
may have added another whatever they're called, another beacon or whatever they're called on the side of the towers.
hmm
Um, but initially, your plan is still there. You can
Yeah.
go back and reuse the same recycle. It's all about recycling these days, isn't it?
Yeah.
Being greener to the environment, etc.
Yeah.
You can go recycle the mission.
Yeah. And if you're a sort of if you're a telco and or if you're an asset owner and you have a fixed budget for these inspections, instead of allocating it on one inspection, which will cost so much, that basically takes out your entire budget.
Yep.
You could split that into many more frequent inspections over time, and you
Yep.
still spend actually you spend less money overall. So you save essentially your budget that they can allocate elsewhere. But even if you spend 50% of what you allocated before, you can get many more inspections done, which obviously lowers cost, lowers risk,
Hmm.
and you can track your asset better to understand what the condition is really like and how it's changing, whether it's getting worse and how quickly it's getting worse and how quickly do you need to act, because that's where the value is, right? Like it's on the
Yeah, yeah. I
capital
mean,
side.
it's all in the savings.
Mm.
You know, again, how much would it have cost to hire out a scaffold platform, or a cherry picker, or have a man go up and physically check the tower or survey the tower?
Yeah.
When you can use either an in-house drone team if that's what you have, or a third party can come out and inspect it for you.
Yeah.
There's got to be savings to be had.
Yeah. And I think savings to be had in an always connected world, it's one of those things where I think that getting cell towers out of operation just because you want to climb and inspect them is just something that's not feasible given the demands of our 21st century, where we just need
Yeah,
to have operation and
and
coverage all the time.
in
So
however many years we've gone from 2G to 3G to 4G and now 5G.
yeah,
The world is a connected place.
yeah.
So the last thing you want is for one of those, for a tower to be down for X amount of time,
Mm,
to have someone inspect it, or to do whatever with it.
yeah.
Yeah.
So it's just cost savings on so many fronts. It's safety of the personnel.
Yep.
It's no downtime, frequent inspections.
Yep.
What's not to like? I mean,
Time is money.
this is amazing. Yeah.
Time is money, as they say.
Mm.
Nobody
Um,
likes to spend money.
spend money on things that don't need to, because
Well,
it's a
yeah,
cheaper way of doing it. Uh,
exactly.
um,
Exactly.
yeah. So say you are inspecting a cell tower, then
Yeah.
what would be the typical use cases, typical deliverables? Um, what kind of things would you be normally
What
trying to shoot
looking
for?
for on a cell tower?
Yeah.
What's inspection wise? I mean, you could have anything from a broken antenna, broken dish,
Mm,
frayed cables, even the structure itself. There are big metal, that obviously the large frame ones, as we've
mhm,
seen some from clients in Africa,
mhm,
are a large metal framed structure. I mean,
yeah.
most of them here are on a pole,
Mhm,
but the larger ones are all metal. You can have degradation in the metal that can cause, you don't want the tower falling down with all that kit on it.
mm,
So it can be used for a whole host of things. Anything from the actual communication side to the longevity of the actual structure itself. It's
yeah.
holding up all the equipment.
Yeah. And it could be that you already know the problem areas and you just need to be able to take the right images in
Yep.
in those areas, or it could be that you need to actually scan the entire asset and you want to figure out where the
Yeah.
issues are, so you want to maximize the coverage. So yeah, and those two could be completely different tasks. I mean, one
Yep.
is to create, sort of just take the 2D images in the right places if you know where beforehand, which can be hard for the first inspection.
Because you've got to know where they are.
Because yeah, exactly. You don't want to miss anything.
No.
Um, Whereas scanning the entire asset could present a number of different challenges, which we'll get into.
I mean, it presents a number of different challenges, but also gives the opportunity to. I know we're going to talk about this later, aren't we? It also gives you a chance to have a look at the whole asset in one go.
Yeah,
I've jumped
and
the gun.
yeah, it's okay. Yeah, why not? I mean, let's we could talk about that now if you want. So, I mean, it's interesting that with drones you have the versatility to be able to scan the entire asset or scan only a part of it, and if that's what you want as your use case or your deliverable, then
Yep.
that's what you can do. And and one thing is not necessarily better than the other.
Yeah.
So we see a lot of people create 3D models, but you don't need a 3D model for every single inspection. Um,
No, they're a nice to have,
mhm.
and they have their uses. But you're right, you don't need one for every single op.
Yeah. And other places you definitely need one because that's the
Yep.
only way. If the tower is really tall, maybe, it's very hard
It's
to
hard to
actually.
visualize what's going on
Mm.
60 odd feet above your head.
Yeah.
You know, you're not going to get a ladder up there.
Yeah. And if you just
You
look
wouldn't
at
want
the
to.
images, you can't really tell
No,
where is this
exactly.
image in vertical spaces.
In conjunction with the rest of it.
Yeah.
So yeah, yeah. So 3D modeling certainly has its advantages for stuff you can't physically visualize from the ground.
Yeah. Um, but when it comes to cell towers or cell tower inspections, isn't most of the challenge on the operational side? Would you say? Or
I mean, once you you know, collecting the data, if we're
Mhm,
talking drone side of things, you know, the actual collection of the data, um once you've assessed how to build that mission,
mhm,
the data collection, as long as the mission has been built correctly,
mhm.
is actually fairly simplistic.
Okay.
So this is what I found anyway when I was out um, collecting data for our demo cell tower.
Mhm,
Um, I mean, obviously challenges do come with, you know, if you've got obstacles, trees, for example, you
mm,
know, a lot of cell ones in town. You may have buildings.
mhm.
Certainly, ones in rural areas, you
Yeah.
know, may have a tree line around them, which I
Yeah.
found when I was out.
Yeah.
So it's just getting your distances right, you know, making sure that you've got the part of the tower that you need. Obviously, when we went out, we didn't do the whole tower.
Mhm.
We only think we did the top quarter of the tower. So we
Yeah.
got all
Top
the
course.
mast and everything else in. But there was a
Yeah.
tree line,
Yeah.
which obviously I couldn't go all the way around the tower because I've
Mm,
ended up
yeah.
in a tree,
Yeah.
which is
So
not
how did
good.
you deal with that then? I mean, what do you do
So
to
I
mitigate?
mean, planning the mission.
Hmm.
Should we go into mission planning? Should we talk about mission planning and how we do it in Hammer, for example?
We could do that, or we could just talk about generally as well. Like, what did you um
So I
hammer?
mean, to define where I could actually fly safely,
Hmm.
um, I originally took the drone up,
Hmm.
took it to this obviously to the side of the tower where the tree line was,
Hmm.
and figured out the exact height of the tree line.
Hmm.
So obviously, when I was planning my mission shortly afterwards, I knew that my bottom altitude, my lowest level altitude,
Hmm.
was at least, I think I was at least 6, 7 foot off the top of that tree line.
Right. Mm.
That way, when I knew I was running the mission, which we ran in circles as opposed to up and down,
Yeah.
when it came and did its final low altitude circle,
Hmm.
I wouldn't end up in the tree,
Yeah.
which is where I did not want to be.
Yeah.
Admittedly, at the time, it was quite blowy.
Hmm.
So I did actually lose a little bit of altitude,
Hmm.
which is when I thought, safety first, I'll bring the drone back in. By which time I'd already caught,
Yeah.
I'd already caught 2 passes. So it
Yeah.
was fine.
Yeah.
But I mean, it is when you're out there, it's all about, we talked about this time and time again in podcasts and in our blog post. Safety,
Yeah.
safety is paramount to
Yeah.
when you're flying.
Yeah.
Um,
It's good to talk about it as many times as we can because I think it's one of those things where, in aviation they say this thing where, the probability of a catastrophic event is low, but the intensity of it is high. So
that's
when you
it.
multiply those two together, you end up with something high. So if you
Big
want to,
mess.
yeah, big mess.
Yeah.
Whereas, you've got something on terrestrial, the frequency is higher, but the intensity is lower. So,
Yep.
um,
Yeah.
so, so if you want to be in the aviation industry, which I think drone industry does have a lot of overlap with.
It does.
Um,
We're on the edge of. I mean, obviously, it is aviation. We are in the air,
mhm,
but it's on the. There is a fine line between the two.
yeah,
There's a bit of crossover.
yeah. How did you deal with magnetic interference, or did you find any, or was that because that's a big
Um,
question around cell towers, isn't it?
yes, yeah. So I mean, I don't know how much of it's rumor and how much of it's truth because obviously I haven't surveyed that many cell towers.
Mm-hmm.
Um, when I was there, I didn't really have any interference, so
Hmm.
to speak. But
Hmm.
that doesn't mean to say that you won't get interference from other towers. The
Hmm.
one we did was quite a small,
Hmm.
probably a low yield, low wattage tower.
Yeah.
You might find some of the ones in more built up areas, or some of those ones that have to, be able to transmit or receive from further distances, transmit from further distances, may have larger arrays on them. So you might get a microwave dish on it, which drones, they generally don't like any interference at all. So I was lucky when I was out flying, I didn't get any interference apart from the howling wind, which was a big issue.
Yeah.
But it was fine. You'll generally know when you've got interference.
Yeah. You feel the drone's behavior is completely off, right?
Yeah, it gets upset. I mean, a lot of mag interference will come from the ground, which is what I've experienced in the past. Before you take off, it'll tell you there's too much magnetic interference. The drone generally won't take off, or if you manage to take it off and it still hits magnetic interference, it'll act strangely and generally freak the pilot out somewhat. And then it's time to bring it back in and have a breather.
Yeah, it's good to have those warning signs, right? Freak the pilot as soon as possible.
To get the pilot's heart rate going, squeaky bum time, as it's known in the industry.
I'd love to see a graph sometime, when magnetic interference happens correlated with pilot's heart rate,
heart rate
on a graph. There'd be a great correlation and causation trend over there.
Many times in the past where we have had what's known as squeaky bum time, where you're like, just bring it in, land it. No, not in survey terms. In filming and in anything. When you've got a drone in the air, you can experience issues. But luckily, you have to be ready. Fingers on the buttons, kids. Get that drone back in. I was lucky. The cell tower I did, I didn't get any interference at all.
And it seems it's like a statistic thing where statistically it all depends on. There's no global data set to say whether you would find interference with drones in any given cell tower or not.
Nope.
I think the best thing to do is to take the drone up manually and to do a test flight manually at a safe distance to see if you're getting any interference or not before you do the mission.
When I flew, I took it up and I got close on all sides. That was not only to measure the tree height and find my safe distances. It was also to see whether I was going to get any interference, which didn't happen.
Which is good.
Yay. Which is very good, actually.
What about battery changes? Did you have any battery changes in the middle of the flight?
I didn't have any battery changes, but again, battery changes, much like our other missions, it will get to a certain percentage depending on how you've set it. Because obviously you can set what level you want the battery warning in Hammer. It will, it'll warn you that the battery's low. Bring it back in, change the battery, resume the flight. It will go up and it'll go up and continue. Yeah.
And I think with especially the tower mission that we have, one of the things that we built in is that if the battery change happens on the other side of the tower and the drone is below the tower's max height, the drone would first go up to the go home height over the top of the tower.
Over the top.
And then return.
Which I did actually notice. The first time I flew the tower, which I won't talk about because that was quite nerve-wracking that time. Squeaky bum time. Yeah, do you know that is actually in the English dictionary now? I think.
Oh, is it?
Thesaurus or whatever. Yeah, I think I've read something somewhere about that. I did actually notice my start point was the other side of the tower, and it did avoid the tower to get to the start point.
Oh, right, okay.
Which I thought was great.
Yeah, of course. We mark it as an obstacle on the map, so.
Exactly. And then the mission that time round went wrong, which I will explain. Shall I explain that now?
And why? You could.
Yeah. So when you're planning a tower mission, which will also be in our latest video, which will be completed at some point today. When you're planning a tower mission with our software, obviously you get the map.
Yeah.
On the map, what is a tower on a map? Flat. So you don't know from the map where the top of that tower is. So originally I did an experiment and I marked it up on the map back here at the office, and I took it to the field. And of course, when it goes up and flies, the tower is completely offset. So on one side of the tower might be 8 feet away from the tower. On the other side of the tower, you might be 15 feet.
Yeah.
Because it doesn't know where the center of the tower is.
Exactly.
So this time round, I experimented a couple of times with that. Then I got the fear, and then I came back to the office because the last thing I wanted is my drone slapping into the side of that tower.
Yeah.
So I came back to the office and I didn't replan it in the office. Right. I came back, got everything sorted, went back out into the field. And then what you can do is you can take the drone up, bring it over the top of the tower, select your tower mission, and then press C2 on the back of your controller. And what that does, you basically point the camera to Nadir so you know where the top of the tower is over the top of it. Press your C2 button, bosh, up it comes. It then knows where the center of the tower is, and you can go back and you can either bring the drone down, plan the rest of your mission on the ground, or you can move at a safe distance away from the tower, plan the rest of your mission in the air, which is very quick to do.
So to unwrap that a little bit more,
unwrap it.
Yeah, so essentially that's the fly to draw feature, and the idea is that you fly to draw the mission. As it says on the tin, basically fly to draw the mission. And the C2 button is the button on the back right of the controller.
Back right, yep.
But it could also be a different button depending on how you've configured the remote controller. If you don't have a C2 button, you can also press the drone's icon on the map to essentially take the drone's current position and input it as a point onto the map. So, and you can do that with all the other settings as well, like flight radius, so radius away from the tower,
altitude,
bottom altitude, everything that you need to essentially draw, but you're flying to draw that. You can kind of
which is actually what I did with when I was up there on that second run, to get the correct lower altitude above the tree. I used tap to fly, tap to draw. So I used the drone icon to mark the bottom altitude, because obviously I could see the drone, I could see it was at a safe distance above the tree. That's my bottom altitude. That's where I want it to be.
Brilliant. Yeah. So that's probably the best way right now, because there is no, if it's the first flight you're doing, then Google Maps and the real world are not, consistent across the board, they're internally consistent systems, but there are offsets between Google Maps and the real world.
Yes.
And so, and drones GPS has a different system. So they're all internally consistent, but they have offsets with each other. So as long as you use the same system to measure and the same system to fly, then you're in good hands. But if you're not doing that, then you can have issues.
Especially when it comes to towers, whether it be cell tower or whatever, 9 times out of 10, maybe in places like London, it'd be slightly different, because some of it is 3D rendered in London. But I know with us, trying to plan a tower on a flat map is not the easiest task. But with the draw to fly or the tap to fly option while we're out in the field, where you can actually mark the center of that tower, just gives you a huge advantage.
Exactly. Yeah. And did you do orbital flight plans that were height first or width first? So did you circle first and then go down, or did you go down as up and down and then go around?
So I was originally just going to do up and down. Actually, I just ran circle.
Right.
So it just circled the tower from top altitude to bottom altitude.
Right.
I would like to get back out at some point and do, the up and down from top to bottom all the way around.
Yeah.
Just to see what sort of different data set we get.
Yeah.
If any.
Yeah, I think in some sense the up and down is more efficient because you're covering the largest edge of the structure first.
Yep.
But it's less safe in the sense that you go up and down quite a lot.
You
a
do.
Lot more.
And when you're around the back of the tower, not so bad with the tower I was using. It was quite a skinny, the pole was skinny and there wasn't a great deal of devices or aerials or whatever you call them, dishes on the top of it. So I would have been able to see the back side of it. But if you're doing a large tower that's, it's quite a chunky structure, the moment it goes around the back, you lose, and you lose sight of it. And you may be able to get around and see it. Certainly where I was, I couldn't get around the back of the tower because it was all shrubbery and trees and whatnot. So I couldn't get in there and have a look.
Yeah.
So it depends. I guess it all depends what, your preference.
Yeah, and line of sight and safety go hand in hand. So that's really challenging to maintain line of sight and make all these decisions on the field.
But hey, we have two options. Does anyone else have two options? You can either circle it or go up and down it. It's up to you.
True. Yeah.
So
true. And
advantage hammer.
Hammer won.
Hammer wins.
Hammer wins. No, I think it's one of those things, right? Like we can really provide tools, but ultimately it's still the pilot and the operator making these decisions on the field. We're still not at that point where we can automatically just decide this stuff.
No, I mean the automation is, it is just a tool to enable you to get a job done, quicker, possibly safer than you do it manually, and collect high quality data at the same time. We're not out there, going, you just press play and it goes, and you can sit down and have a cup of tea,
can of
coffee, or a can of Coke, which I haven't got, but I'm just having coffee today instead.
Is that a Star Wars mug I see, Alex?
Yeah.
There we go. Of course, there we go.
Other movie franchises are available. This happens to be my favorite. So yeah, I mean, I got sidetracked there with the whole Star Wars thing.
You got Star Trek there.
I got Star Trek, Star Wars. So yeah, I think when it comes to tower missions, having the options are there, but it is all about the how the pilot or the end user creates that plan and executes it. We won't be held accountable for you smacking your drone into the side of a building.
And nor will
have we got that have we got that waiver anywhere on the website? It's not our fault.
Everyone's got to have insurance, everyone's got to use the right policies. It's just it's a difficult industry, right? Because you got to make sure so many things, you have to cross so many T's and dot so many I's and make sure that everything just goes according to plan. But it's all worth it because your feet are safely on the ground, and people are not climbing these things, which is still way worse than any other risk that you would take as a drone pilot, say.
Exactly.
And the drone platforms are getting smaller and smaller. They're able to do so much more with, smaller drones are able to carry high-end sensors. I think we're going to get to a point where the drone risk is going to be negligible from the perspective of anything realistic happening. Also, the technology is getting so much better in terms of obstacle avoidance sensors and, automatic go home sensing, and there's still going to be physics like wind, and your drone can't do anything about it. But I think that we will solve these challenges both from an operational standpoint and from a technological standpoint, so that the risk is so low that it's not even.
I mean, with every release of drone, they've found new ways of mitigating risk. I mean, even the Mavic 3 Mini Pro. They just want to add more letters to their aircraft all the time. Even that's got some really good obstacle avoidance on it. It's tiny. You can't fly it above kind of 10 miles an hour, 10 to 12 miles an hour, because it'll just off it'll go. But and the picture quality on that's great as well. So that every new release of kit, they're releasing new ways of keeping that aircraft safe.
And ultimately, it boils down to what you were saying earlier. It's about the high quality output.
It is.
So, it can be challenging with everything that we've discussed, structures around the tower, whether you go up and down, whether you go in circles, how you mark the tower, how do you look at magnetic interference or not. A lot of operational challenges, but ultimately you're trying to get to a high quality data set that you can then do an inspection off of. Which brings me to post-processing. So assuming you've got a high quality data set, how do you think about processing that data? How do you think about kind of making that data available to your end customer in a consumable way?
Well, I mean, we've talked about 3D.
Hmm.
You can obviously with the Hammer platform,
Hmm.
you'd upload that as a project. So you've got the entire project there. You can then post process it into 3D
Hmm.
inside the project. That
Yeah.
makes sense? Yeah. So you can post process it inside the project into 3D.
Hmm.
So your client or your end customer has a 3D representation of the data that you've collected.
Yeah.
You've also got each and every shot you took while you're
Hmm.
out there from top to bottom, round
Yeah.
and round.
Yeah.
You can then annotate that data,
Hmm.
sorry, as a pilot you might not, but the surveyor will. The
Hmm.
surveyor can annotate that data, say, oh, look, there's a broken cable, or
Yeah.
that dish isn't aligned correctly.
Yeah.
Um, you know, that's vital for the upkeep of not only cell towers but anything like we've talked about before, like facades or roofs.
Yeah.
To be able to pinpoint what's wrong in any given area
Hmm.
in that map, or or that cell tower or that roof, or
Yeah.
you know it's
And that has to be done in a 3D platform because even if you don't have a 3D model, it needs to be in a 3D representation of all the images because,
yeah,
as you mentioned, cell towers on a map are
flat,
flat. So
useless,
useless,
flat.
flat.
Yeah,
So you need a 3D environment to be able to see, well, this is the dish on the, top quarter of the tower as opposed to the middle of the tower or wherever. If you don't have that context for a vertical structure, you can't do the inspection. I mean, it's all good to have, 200 images of a cell tower, but if you don't know where they are in 3D space and what they
yeah.
map to, then you're basically losing time trying to sort of figure out where they are on the tower, where you could
Some of
just.
these, I mean, some cell towers are so complex when you look at them. I mean,
Mm,
as wasn't particularly, but you get some of the big inner city ones, they've got so much on them
mm,
that, if you just give a photo, give a picture over to a surveyor and go, well, look at that, what's wrong with that? He'd say, whereabouts on the tower is that?
yeah,
So to have that representation in 3D, you can go, well, actually, that's there around that,
yeah,
around
yeah,
that side.
yeah.
Yeah, makes perfect sense.
You could also have two cell towers really close to each other. And you could end up with, I mean, if you were surveying both, so if let's say you were capturing both of them, and now you've got 200 times 2, 400 maybe photographs of all the two towers. You don't know which one is which. And so,
No, they all look the same.
yeah, they all look the same.
Same, yeah. They obviously don't all look the same, but it's
To a
good
human.
to a human. Yeah, they do. It's all good to have that you know the ability to be able to pinpoint exactly where what you're looking at, what you've
Mhm.
got to assess, and what you've got to fix,
Yeah.
and
Uh,
we can do that.
Yeah. And it's one of those things where, I think that the digital twin revolution that we're going through at the moment, it makes sense because we are pretty bad at sort of just looking at an image uh, in its own right and then looking at another image which looks very similar and then
Yep.
trying to sort of say where it was in 3D space.
Yeah.
We're quite good at doing it maybe in 2D, but when it gets to like 3D, it's
It's hard. It is hard to do.
yeah, it's
It
hard
is
to
really
do.
hard to do.
And a cell tower
Yeah.
looks very similar from many different points of view.
Yeah. Yeah. Especially I mean, the complex ones. There's so much going on with them. To be able
Mm.
to have all that information and all that data to sift through and know whereabouts in 3D space,
Mhm.
um, it should be
Mhm.
perfect.
Yeah. And then if you're using, I mean, obviously, like we don't we can't sort of force anyone to use the cloud, but if you are using the cloud, one of the advantages of doing the 3D space visualization on the cloud is that your end customer or stakeholder and you can have a shared view into the same cell tower
Yeah.
as
Yep.
opposed to a copy of it, which does happen. I mean, if you don't use the cloud, then you end up inevitably creating a copy and sending the copy. And then, they're talking about the copy and you've got another copy on your side and things just don't align. And
Well, I mean, with the annotation side of things, if you've both got the project and it is shared in the cloud,
Mhm.
you know, your client can annotate, add notes, which
Mhm.
you'll then be able to see.
Yeah.
as opposed to going, oh, that bit round the back of the tower,
Mm.
where that cable plugs in. And you're
Yeah.
like, I don't know what you're talking about.
Yeah.
There's lots of cables that plug in around the back. If you've got a shared project and you're both able to view it at the same time,
Yeah.
you can both report on it and do what you need to.
And yeah, collaborate. And the same is true
Collaborate.
for,
That's the word I was looking for.
yeah, annotate and collaborate. Um, so I mean, and if you're an in-house team, then you could, I mean, obviously there could be an operational team that's flying the mission. There could be a sort of an analytical team that's analyzing the data.
Yep.
And the two teams could actually collaborate and sort of sync up on this one cell tower. I know it seems like it's one of those things where it's such an important thing to do, but ultimately, um, now the tech has gotten to that point where you can do these things without sort of writing things on a paper or just taking photos from a ground-based camera. You can actually build these 3D models in the cloud over time,
Yep.
which is almost a 4D model if you think about it.
Well, yeah.
Um,
I mean, because you can go back and you can repeat the same work, and
yeah.
that workflow may change.
Mm,
With additional, if we're talking cell towers, you may have additional modules that get attached to the tower. In
mm,
the next time round, that'll appear on your next 3D map.
yeah.
You know, in an
Yeah.
in an update process.
Yeah. And I think the things that are now on the edge, that I'm pretty sure will become mainstream over the next 5 years or so, is all the AI movement on the data sets. Because once we have enough data sets, we can then start looking at all the annotations, and then
Yep.
you could have AI just sort of pick out, well, this dish looks definitely broken,
Yep.
and this wire is not plugged in here,
There's
and
rust. There's rust
rust.
here. There's anything you could imagine. AI could eventually look for and
Mm,
and define what the issue could be. And
yeah.
obviously, it's never going to beat the human eye, but it gives you an indication into what you might need to look out for.
Yeah. It's sort of different layers of abstraction where you start with, maybe the first layer is just the images.
Yep.
The second layer is a 3D visualization of those images, but not a 3D model.
Yeah.
The third layer is the 3D model, and the layers below it. And then you have the AI layer on top of it, which is figuring out all the defects and issues. And maybe there's a fifth layer, which will be, again, something that AI will solve, is looking at all the layers below it. So the defects, the 3D model, the images, and the 3D visualization. What is the best course of action? How do you
Yeah.
act on it? Um, you know, some form of a repair plan or some form of that's probably like quite in the future, I would say.
Scary.
It's scary, but possible.
Scary but possible.
Yeah.
Yeah. Yeah. I mean, I know we mentioned, sorry, I mentioned the whole, Skynet and all that gubbins every week, but it's true,
Yeah.
with the way AI is going, and the future of what is possible through it.
Mhm.
Scary times.
Mm. Or
Or
not,
not.
or not.
Let's hope
Yeah.
not.
Why do yeah, There's also the thing, like, let's hope not. We can only hope.
We can only hope,
It's not going to
indeed.
be under our control.
No.
But maybe it's a time of just, amazing, like a time of abundance of great
Yeah.
things, because just people are not spending time sort of climbing towers anymore, and it's just all done and dusted by machines are taking over all of
Yeah.
that. So we can spend
I
our
don't
time
think I don't think it'll
being
ever
on phone calls used for these used
yeah, using the cell towers to what
using
they're actually supposed to be used for. I don't think AI will ever take over the human intervention side of things, but it will certainly decrease the workload
Mm,
of human input.
yeah.
Because it'll get to such a point where it'll be able to detect that
Mm,
that's what's wrong. It'll inform you, and you can have a quick look at it and go, oh yeah, that cable has come out,
yeah.
or whatever, or that dish has moved.
Yeah. Yeah, I think if we divide it into sensing and then actuation, the sensing parts of it might be something that AI takes over completely. And, you know, you have everything from the data capture to data processing to analytics, all in the sensing stream.
Yep.
And then you've got your actuation stream, which is where someone has to fix something for this to get better. I
Yep.
think that is hard for AI or robots to do much about at the moment because these are really complex tasks. but we're also seeing humanoid robots come to the market and all sorts of things. So, you know,
Go on, Mr. Tesla.
You never
Hasn't
know.
he?
I mean, Boston Dynamics has actually one of some of the best robots that we've seen.
Those robot dogs are
but-
just awesome.
Yeah.
We saw those the other month. They were incredible.
Yeah.
I kind of want one.
Even the humanoid. Have you seen the parkour videos?
I have,
Yes.
yes. Aren't Tesla releasing a lower budget humanoid robot?
I think they have, yeah.
Yeah, I think he's coming out fairly, or she, they
Yeah.
are coming
Optimus.
out. Yeah, they're coming out fairly soon, and they look kind of cool. They can't do like major tasks and stuff yet, but it's only a matter of time, isn't it?
Yeah.
You know, the Boston Dynamics dogs, they can do all sorts of things now.
Yeah.
And they look really cool.
Yeah. So I wouldn't be surprised if a drone captures all the data, and then some AI processes it and then tasks the dog to go fix it. That kind of
that'd be nuts, wouldn't it?
That'd be an amazing pipeline.
Can we get one? Can we get one of these dogs?
Maybe
not a Boston Dynamics one because that's stupid money.
cell tower inspections with a robotic dog.
Yeah, that'd be interesting. To climb the tower. That'd be fun to watch.
That would be scary.
That'd be a lot of money down the can as well because it probably wouldn't make it. Yeah, maybe we'll leave that one for a bit.
Never say never.
Never say never. Yeah, or Never Say Never Again, which was a Bond movie.
Oh, there we go.
There you go. You see,
well,
Sean Connery.
Well, you're the filming expert here for sure. Yeah.
Cheers.
Yeah.
I probably watch far too many films. My wife says I watch far too many films. She can never quite figure out which one film is from the next because I just watched so many of them. But there you go.
There we go. Yeah. So
that's about
today,
my home life.
coming back to today.
Yeah.
So today we've got high quality data. We've got safe operation of the drones. And you've got repeatability so that you can collect this data over and over again so that you can build that predictive maintenance future that we're probably heading towards. And I think being able to do these things are still extremely hard. I mean, we talk about AI and we talk about robots and all these things, but it is still bloody hard to get a good quality data set.
It is.
Yeah.
It is. And to get consistent data, I mean, even with the cell tower isn't easy, but we're forging ahead, and and they do say some data sets we produced from not only our own but other people's data sets with cell towers. Some of them look really, really good.
Yeah,
really good.
Yeah, and we can totally see that that's the way all these inspections will go in the future.
Yeah,
because the quality is higher, cost is lower. It just makes business sense. It just makes all sorts of sense, even from a risk and a safety standpoint.
Yeah.
So it's great to be in this industry now, and I think the time is now. So there's a lot of people that are in this industry now doing these things will definitely look back and be like, well, that was an amazing time, and things were just
on the forefront of the technical evolution.
Yeah.
My new book.
That's the book title for this week. There you go.
On the forefront of the technical evolution. I must write that down. Yeah. I don't know what the book's going to be about. Probably AI and robots and stuff.
Don't forget the cell towers.
I'll add some cell towers and maybe some Boston Dynamic dogs in there as well. And
the robots need to talk to each other through the cell towers. I mean, they can't talk to each other without the cell towers, right?
That's awesome. I like that.
So they're maintaining their assets.
Get some ideas down. Cool.
Brilliant.
Good chat yet again.
Thanks, Alex.
So as per usual, everyone, you can give us a like, subscribe. If you want to get hold of us, give us a shout on team@hammermissions.com, and also subscribe to our podcast, which is available on all good podcast directories.
There we go. You perfected that message now.
I have, yeah. It's drummed in. That's what it is.
Brilliant. Thanks again,
Alex. Nice one, Varun. No worries. And I shall catch you soon.
Yeah, catch you later.
Cheers.
Cheers. Bye.
Bye.